my dear boys and girls. Welcome to your science class. So last class we learned about the measurements, different measurements used in order to measure the different measurements we use in our daily life. We learned about the standard SI units of physical quantity in last class. Today we are going to learn a new topic in this chapter, that is about rest and motion. Rest and motion. Now, when is a body said to be in rest? An object is said to be in rest if its position remains the same, isn't it? So when you look around, you may be seeing the windows, the doors, the chairs, tables, etc. Isn't it? All those things are remaining in their own place. They are stationary in nature, isn't it? So such things are on rest when we compare it with their surroundings. So that is what a resting body is. Now how will you define a body in motion? Yes, an object is said to be in motion if it changes its position based on its surroundings. For example, when you look up onto the sky, you see the birds flying. So those birds are moving to one place to another. They are having the motion. You understand it when you compare those things with the surrounding region. You understand that the movement of that object when you compare them with the surroundings, isn't it? So that is how we define an object in rest and motion. So an object is said to be in rest if its position remains the same with respect to the stationary objects in its surrounding. And an object is said to be in motion if it changes position with respect to the stationary objects in its surroundings. So an object which is in motion, the surrounding change in surroundings happens, whereas an object in rest will remain as the same surrounding. It will have the same surrounding. Now what we are going to see is the type of motions. So dear children, motion of different objects are classified into 7 types. So today we will learn all these 7 types of motions. So the first type of motion is translatory motion. Translatory motion. So what is this translatory motion? An object is said to be in translatory motion when all parts of the objects move the same distance at a given time. Then the motion of that object is said to be in translatory motion. That is, all parts of the object moves the same distance in a given time. So such objects are said to be in translatory motion. Now there are 2 types of translatory motion, that is rectilinear motion and curvilinear motion. So from the word rectilinear, you may be understanding that is such objects will be moving in a straight line. When object moves in a straight line, then it is called rectilinear motion. As example, we can say a car moving on a road. So the car is moving straight on the road, isn't it? So that is an example for rectilinear motion. And another example is a ball falling down. So that ball falling down moves in a direct line, straight line, isn't it? So that is also following rectilinear motion. Now the second type of translatory motion is curvilinear motion. From the word curve, you may be understanding that the body is having a curved path, isn't it? The object moves along a curved path. That motion is said to be in that translatory motion is said to be curvilinear motion. So you may have played the throw ball game. So in that game, you know the ball will be moving in a curvature, isn't it? So such curved path is said to be in curvilinear motion. And another example is when you throw the javelins. You may have seen the players throwing javelin. It has a curvilinear path, and that motion is also said to be curvilinear motion. So we learned about translatory motion. When an object moves in the same distance in a given time, it is said to be in translatory motion, and there are two types of translatory motion. First one is rectilinear. That rectilinear motion object follows a straight line, and the second type is curvilinear. In curvilinear, the object follows a curved path. And also we have seen the examples.
Rectilinear motion. When an object moves along a straight line, its motion is called rectilinear motion. Some examples of rectilinear motion are a car moving in a straight line, motion of a striker on the carom board. Curvilinear motion. If an object moves along a curved line, its motion is called curvilinear motion. Some examples of curvilinear motion are a car moving along a curved path, a ball thrown by a boy are all examples of curvilinear motion.
Now the second type of motion is circulatory motion. Now from the word itself, circulatory motion, you may understand the meaning. That is, it is forming a circle, isn't it? The motion is in a circle form, isn't it? So when an object moves along a circular path, it is said to be in circulatory motion. Now teacher will give few examples of circulatory motion. The first one is the movement of earth around the sun. The movement of earth around the sun. You learn about the solar system, you may know that sun is in between and the earth and other planets are moving a circulatory motion around the sun. So that is an example. Now the movement of moon around the earth is also another example. And also in clocks and watches you may have seen the second needle, isn't it? So the movement of the second needle is also having a circulatory motion.
When a body moves along a circular path, it is said to be in circular motion. For example, the earth moves round the sun in a circular path. Some more examples of circular motion are movement of the moon around the earth, motion of the tip of the hand of a watch or clock.
Now the third type of motion is rotatory motion. Now what is this rotatory motion? So you are familiar with the word rotation, isn't it? So rotatory motion, an object is said to be in rotatory motion when the object moves about a fixed axis without changing its position. So the feature of the rotatory motion is the object will be fixed at a place and it will be moving around and it will be rotating on this fixed axis without changing its position. Now teacher will give you a few examples. When you observe the motion of the fan, so on the top the fan is fixed, isn't it? And it is having a rotation. So such motions with an axis without changing the position is what we call rotation, rotatory motion. The wheels of the sewing machine you may have seen. A single wheel will be rotating on the sewing machine. That is an example for rotatory motion. And the spinning of the top, when you play with the top, spinning top, you may have seen it will be having a single axis and the top body will be rotating on the single axis without changing its position. So that is also an example for this rotatory motion.
A body is said to be in rotatory motion if it moves about a fixed axis without changing its position. For example, the motion of the blades of a fan and a spinning top all show rotatory motion.
Now the fourth type of motion is oscillatory motion. So what is this oscillatory motion? The object is oscillating. What will be the nature of the object's movement? Yes, it will be having a to and fro motion. So you may have watched the oscillatory motion on the pendulums. That is, the object will be having a to and fro motion about its mean position. The position will be same, but it will have a to and fro motion. So example for oscillatory motion is the pendulum of a clock, and also when we swing in parks and all, when we swing, we will have a to and fro motion, isn't it? Our body will be moving a to and fro motion. So that is also an example for oscillatory motion.
Oscillatory motion. When a body moves to and fro, backwards and forwards about its mean position. Its motion is called oscillatory motion. In oscillatory motion, the entire body moves to and fro. Some examples of oscillatory motion are the motion of a swing, the pendulum of a clock.
Now the fifth type of motion is vibratory motion. Vibration, you may have noticed the vibration in guitar and all. What is its peculiarity? When the vibration occurs, the two ends of the motion of the object will be still, but the middle region will be vibrating or moving. It will have a to and fro motion. So an object is said to be in vibratory motion. The object moves in such a way, a part of the object always remains the same and does not move, while the rest of the part will be moving to and fro. They will show to and fro motion. So example for vibratory motion is the movement, the motion of the guitar string, as well as the movement in the heart. So these are examples for vibratory motion.
Vibratory motion. Pluck a string of a sitar or a guitar. You will see that only the string moves, not the whole body of the sitar or the guitar. The motion of the string exhibits vibratory motion. The motion in which a part or parts of a body always remain fixed and do not move, while the rest of the body moves to and fro in a definite style, is called vibratory motion.
Now the sixth type of motion is periodic motion. The peculiarity of periodic motion is this motion repeats after a regular interval. The periodic motion goes or repeat after an regular interval. Now the example for periodic motion is motion of earth, which cause the variation in the seasons. So the motion of earth around the sun, and it caused the changes in the seasons, isn't it? So that is an example for periodic motion. Other examples are the wall clocks are example. Pendulum of the wall clock is an example. So such objects are said to be in periodic motions because they have regular interval of time in between this motion. So hence they are called periodic, hence these motions are called periodic motions.
A motion that repeats itself after regular intervals is called periodic motion. The swinging pendulum of a wall clock and the motion of the moon revolving around the earth are examples of periodic motion.
Now the last type of motion is non-periodic type of motion. The motions that does not repeat in intervals, regular intervals, is what we call non-periodic motion. So periodic motions, we learned that they are the motions which repeat in regular intervals. Now, non-periodic motions are the ones which does not repeat in regular intervals. For example, the movement of the hands and legs, etc. are example for non-periodic motions. So children, in today's class we learned about 7 types of motions, and we understood how the motions are classified based on the movement of the objects. There are 7 types of motions, that is translatory motion. The first one is translatory motion, and the translatory motion is divided into 2 based on the path the object follows. The first type is rectilinear motion and the second type is curvilinear motion. Now the second type of motion is circulatory motion. The third type is rotatory motion. The fourth type is oscillatory motion. Fifth type is vibratory motion. Sixth type is periodic, and seventh type is non-periodic type. So while learning all these type of motions, teacher told examples for each type, isn't it? So while explaining the examples, in certain cases teacher told similar examples for each of these motions. That is because when an object moves, it shows different type of motions at the same time. That is because all the object shows multiple motion. All the object shows multiple motion. Multiple motion. What is this multiple motion? Multiple motion means the object possesses two or more type of motions while moving from one place to another or while showing the motion. For example, when a boy rides a bicycle, the wheels of the bicycle shows rotatory motion, isn't it? Because the wheels are fixed at a single point and the wheels are rotating. Hence, it shows a rotatory motion. At the same time, it shows a translatory motion because the bicycle moves in a straight line, a rectilinear path or either a curvilinear path, isn't it? Hence it shows a translatory motion also. So a moving bicycle shows rotatory motion as well as translatory motion. So likewise, a single object shows multiple motion, that is different motions at the same time. And the second example for multiple motion is the movement of earth. Earth rotates in its own axis, isn't it? Hence it shows a rotatory motion as well as it revolves around the sun, isn't it? It shows a circulatory motion also. So likewise, when we consider each object, it may shows more than one type of motion at the same time. So this property of motion is what we call multiple motion.
Multiple motion. Sometimes an object possesses two or more types of motion at the same time. This type of motion is called multiple motion. A boy riding a bicycle is an example of multiple motion. The wheels of a bicycle rotate, rotatory motion, and at the same time move forward in a straight or curved path, rectilinear or curvilinear motion.
So dear children, by this we are ending today's class. We have also completed the 10th chapter. So next class onwards, we will discuss the textual activities of this chapter. So dear children, don't forget to go through your textbook for next class. See you in next class. Thank you.